Hello. Today we learn 2.3, the dot product. So we learned in the vector operation, we learned the vector addition, vector subtraction, and scalar multiplication. Today we will learn about the dot product. So dot product, also other book indicate that scalar product. So we are using notation like a little dot. So here we go. I made with a green here, right? So this is notation. All right, so let's take a look. Dot product. We have a vector v, vector w. We have a component, right? And if we make operation with the two vectors with a dot product, then we multiply component with the component, and we add everything together. Then we can get the result as the what is called the scalar, right? So we will get the scalar result. That's why in other book they say that scalar product. Okay. All right. So let's do it. So we have two vectors. We want to find dot product of two vectors. Yeah. So here we go. So a vector W dot with V. Then the component with the component, we multiply together and then we add them, right? So 3 times -1 plus 5 times +3 times, sorry, plus 2 times 0, right? So we get 12. Okay, how about this? Second questions. So we have P dot product with a Q. So we have 10 times -2 plus -4 times +1 plus 7 times 6. What do we have? We have 18. Is it true? Okay. Now we have a theorem 2.3 properties of a dot product. So we have vectors u, v, w. And then C is the scalar. Scalar means real number, right? And if we have a dot product, then it can be commutative. And if we have a dot product, then we can distribute. All right, so the third one, we have a dot product with we multiply the scalar, right? Then we can express, we multiply with the scalar, with the vectors, and dot product with another vector. We can express that. And the other way, we can do that this way too. All right. And we have dot product with itself, right? Then we can express this one, magnitude of V squared. Okay, let's prove the last one. Prove. So dot product with V. All right, so the component of vector V we can express as V sub 1, V sub 2, V sub 3, right? and dot product and itself. So v sub 1, v sub 2, v sub 3, right? Okay, so we had the experience earlier. Dot product means we multiply first component with the first component, and second component with the second component, and third component with the third component with addition, right? Okay, then that will be v sub 1 times v sub 1 plus v sub 2 times v sub 2 plus v sub 3 times v sub 3, right? Okay, then in that case, the first term we can express as v sub 1 squared, right? Second term, we can express v sub 2 squared. Third term, we can express v sub 3 to the third power, right? Okay, now we are going to use a trick. That's correct, trick. So this is kind of a technique. So we have, let me just copy this one. And then do you agree? This is the same as, yeah? So we make take the square root and then square them. Is it same? Yeah. Okay. Then, we've seen this one before, right? So what is this? This is magnitude of vector v, right? And then we just have a square, then we just rewriting square them. Yeah, that's it. Then this is the same as, can you see that? Let me write down. So this is the magnitude of vector v and then square. So just to conclude, the dot product itself gives us the magnitude of vector v squared. Okay, let's do example. Let vector a equal to 1 to -3, b equal to 0 to 4, and c equal to 5, -1, 3. I don't want to use ABC, huh? Number one. So A dot product would be, and this is C. C is also vectors, right? Okay, let's do it. So dot product, we multiply, right? So 1 times 0 plus 2 times 2 plus -3 times 4. Then C. Let me rewrite C. So that's not the dot product, right? So we writing C this way. C is 5, -1, 3. This is a vector, okay? All right. So inside what we have, it's a -8. Then we have 5, -1, 3, right? Then we can distribute. So we will get -48, -24. Okay. All right. So second part, number 2. So we have A dot product with 2, 6, right? So 2 is a scalar. So A, which is 1, 2, -3. So writing as vector component. And dot product with 2C. 2C is 5, -1, 3, right? Okay, so one more step. Let's simplify inside. So we do distribute. So we will get, it's a vector. So 10, -2, 6. Yeah. So we have a dot product, right? So that will be 1 times 10 plus 2 times -2 plus -3 times 6. Can you please calculate? It's -12. Yeah. So we have a dot product, then we get the scalar as a result, right? This is not dot product, right? So if not dot product, then the result has vectors. Can you see that? All right. So one more, number 3. So we have a magnitude of vector b squared. Okay. So that means we had earlier, right? So magnitude of b squared means, here we go. So dot product with v itself, right? So let's do that. B dot product with b, right? So that means b dot product with b, right? Okay. So what is the vector? So let me copy 0 to 4. 0 to 4 dot product 0 to 4. So 0, 0 plus 2 times 2 plus 4 times 4. What do you get? We get 20. Very good. Good job. Okay, so we have a theorem 2.4 evaluating a dot product. So dot product of U and V is magnitude of U and magnitude of V cosine theta. So let us prove of this. Let me show you this one. Okay, so we have this triangle. And then from the trigonometry, we have a law of cosines, right? So that formula gives us a squared equal to b squared plus c squared minus 2bc cosine a, the angle, right? That's from the formula, law of cosine. So we are using same formula, so we make that vector as the same shape of the triangle. So we have a vector u there, vector v there, and then this one will be vector v minus u. So same shape. But we talk about the magnitude, right? Length. So we make, this is corresponding that, right? So a squared. So we have a magnitude of this side, which is v minus u, and then they have a squared, so we make a square them, equal to, and following same corresponding the side, v squared here, so magnitude of v squared plus c squared, this squared. So magnitude of u squared and minus 2bc cosine theta. So minus 2 magnitude of v, magnitude of u cosine theta. Yeah. Okay. Now we start with left hand side, which is this one. So let's do it. Magnitude of v minus magnitude of u squared. This means twice of v minus u, right? So with the dot product. So v minus u with the dot product of v minus u, right? Okay, then we make a multiply earlier, right? Dot product. So we can do v dot with a v, right? Minus, let's do this one. V dot with a u. And this one minus v dot with a u, right? The last one, we can express positive u dot with u, right? All right. So this one, I want to just say that we just did that earlier. Magnitude of v squared, right? This is the same concept. That's why we got this one, right? Okay. Now this one will be, we have two of them. So we express minus 2 v dot with u, right? And then the last term, we get magnitude of u squared, right? Yeah, that's it. Okay, so left-hand side equal to, let me just copy this one, magnitude of v squared minus 2v dot u plus magnitude of u squared, right? Okay. How about right-hand side? Right-hand side. So this is the left-hand side, and this is right-hand side. So right-hand side, which is, let me copy, magnitude of v squared plus magnitude of u squared minus 2 v u cosine theta. Yeah. Okay. So since we say that this is equal to that, right? So left-hand side equal to right-hand side. Left-hand side equal to right-hand side. So that will be left-hand side. I want to copy this one equal to that. All right. So how about this? Just copy and paste this. Make a little bit smaller. Too late. Okay. Equal to that. Okay, so let's take a look. we can simplify, right? This is, we can simplify, right? And also, this is, we can simplify, right? All right, then we say -2 v dot with u equal to -2 magnitude of v magnitude of u cosine theta, right? Okay, we can also simplify -2, right? We divide by that, right? So then what's remain? Remain is v dot with u, which is magnitude of v and magnitude of u cosine theta. That gives us the formula earlier, right? So dot product. In terms of angle, then magnitude of u, magnitude of v, cosine theta. All right? Okay, let's do this one. Okay, so this is the questions. All right, so we want to know about the angle. Then, since we have this formula, we want to express as a cosine theta. So in the case cosine theta, we can divide by, right? So dot product with a v and u over magnitude of v and magnitude of u, right? So we can express this way too. So let's using that. All right, so cosine theta. Okay, so we can just use one is u, one is v, right? So you wanna express this one as u, and this is expressed as v. Okay, then yeah, it's okay because the dot product is commutative, right? So we can use uv, vu, same, right? All right, so let's do this one. If we are using vector component, that will be 1, 1, 1, right? Dot product. Oh, that's a V, UV. How about, yeah, screw up. So this is a V, this is a U. How about that, right? And 2, -1, -3 over magnitude of V, which is square root of V, which is 1 squared plus 1 squared plus 1 squared, and magnitude of U, which is 2 squared plus -1 squared plus -3 squared, right? Okay, so we still need to calculate dot product of two vectors, right? So that will be 1 times 2 plus 1 times negative 1 plus 1 times negative 3. Okay, then over square root of, that is the 3, square root of, there is a 42, right? So what do you have? So we have a negative 2. Oh, made a mistake. It's a 14. Thank you for pointing out. And over square root of 42. Yeah. So how do you find angle theta? The inverse of cosine. So theta equal to inverse of cosine of negative 2 over square root of 42. So we have a 107.980 degree or 1.88 radians. Okay? All right. Let's do this one. Second. So we have a 2, 5, 6, and negative 2, negative 4, 4. Cosine theta. Just copy. All right, so that will be whatever you like. Say U or V. So V, negative 2 times the positive 2 plus negative 4 and positive 5 plus 6, 4 over square root V, negative 2 squared plus negative 4 squared plus 4 squared and 2 squared plus 5 squared plus 6 squared. Okay, what do you get? The numerator. So we get 0, right? Okay, cosine theta equal to 0. What do you get? Then theta will be pi over 2, which is 90 degree. Excellent. Good job. Okay, let's do theorem 2.5. Okay, so we just did that. Cosine theta equal to 0. And the dot product equal to 0. Then we say that the two vectors are orthogonal vectors. Means that orthogonal means is perpendicular. So let me just make a copy and paste the theorem 2.5 here. see. Okay, so I made a copy and paste here. So theorem 2.5, orthogonal vectors, non-zero vectors, U and V are orthogonal vectors if and only if dot product of two vectors equal to 0. So if and only if we went over on the first section, right? So go to this direction, make a true statement. Go to other direction, make a also true statement, right? Okay, so orthogonal means it's a perpendicular. Oh, no space. Yeah, so that is perpendicular, right? Okay, so also I copy here, determine whether this vector and that vectors are orthogonal vectors, right? So let's find out. Okay, then we have to show that, right? So show dot product of two vectors is equal to 0, right? Okay, so P dot with a Q. So 1 times 10 plus 0 times 3 plus 5 times negative 2. What do you have? Oh, not here. Here. Okay. We get 0. Yeah. So they are orthogonal, right? So P and vector Q are orthogonal vectors. All right. Okay. Let's do hold on 1 second. Yeah. I need to copy and paste definition here. Okay, so we have a direction angles here. So let me just read the angles formed by non-zero vectors and coordinate axes are called direction angles for the vector. The cosine for these angles are direction cosines, right? Okay. We have angle alpha. We have angle beta. We have angle gamma. Let me write down for you later. Okay. So we have a vector V, and looking at the angle alpha, right? So this alpha formed by vector V and I wrote down here, vector I, right? So we learned the standard unit vector, ijk, right? So that angle alpha formed by vector V and vector I. Can you see that? All right. How about angle beta here? What this one formed by? V and J, right? Can you see? How about vector uh, gamma, angle gamma, right? So all Greek, letters. Let me write down later. So gamma, how they formed? Formed by vector v and the k, right? Can you see? All right. Then let me just do one problem. Let's see. Let v equal to 2, 3, 3. Find the measure of angles formed by following vectors. So the first one, just number one, V and I. Yeah, then cosine alpha, right? So we have a cosine alpha. Okay, we had a cosine theta earlier. Then what's the formula? Dot product of UV divided by magnitude of each vectors, right? So U dot with V over magnitude of U, magnitude of V, right? So with alpha in Greek letter. This is a Greek letter. This is Greek. Okay, so we can just replace UV with VI. That's it. So that will be V dot with I over magnitude of V, magnitude of I. Yeah. Okay, what's the V? V equal to 2, 3, 3. What is the I? 1, 0, 0 over magnitude of V, which is 2 squared plus 3 squared plus 3 squared. And magnitude of I, which is 1 squared and 0, right? Rest. Okay, then numerator 2 times 1, and the rest is 0, right? Over the denominator, we have a square root of 22. Which is 2 over square root of 22. Then alpha, right? That's the angle, right? Alpha equal to inverse of cosine of 2 over square root of 22. Then we get 0.426 degree. And this is the same as 1.13 radians. Okay. Now, how do you find the V and J? It's the same concept. Yeah. So let me just make a note for you. Number 2, V and J. Yeah, same concept. Cosine beta. Yeah. Then we are using V dot product with J over magnitude of V, magnitude of Z, right? 3, V and K, right? So V and K. Then cosine gamma. Then we can use the V dot product with the K. over magnitude of V, magnitude of K, right? So with beta 2t, 1t. And this is gamma. Gamma. Yeah. So it's not that hard, right? Just apply the formula. That's it. And then by using inverse of cosine to find degree or radians. Yeah. Good. Any question? Okay, so we're gonna do vector projection. So we have a vector V here. And then we have a vector U. Okay, the vector V, we project onto U, right? So from here to here, yeah. So we say that this is, what's going on? Sorry. Oh, hold on 1 second. Let me do again. U project from here to here. Yeah. Okay. Then we say that from here to here, right? Maybe different color. Project from V to U, right? So we say that vector projection of V onto U, projection of V onto U. Now, how do we write this word? So this way, project vector V onto U. Can you see that? All right. Now, let me show you this. So let's talk about the magnitude of vector projection of V onto U, right? So this is this length, right? Then we take the magnitude. So we have magnitude projection of vector V onto U. Yeah. Okay. Then we say that this is the same as V cosine theta with V is magnitude. Yeah. Okay. Why? Because we did that on first day, right? So in the triangle, so say that this is a vector V. We have X. This is a Y, right? X equal to, so basically R cosine theta, but we say that vector V of magnitude of cosine theta, Y equal to magnitude of V sine theta, right? Okay. Now, this is vector, magnitude of vector V. What's the cosine theta? We just run the formula, right? So, dot product with U and V over U with the magnitude of V, right? Cosine theta equal to okay, then we can simplify. Simplify that, right? Then we get U dot product of U V over magnitude of U. Okay, then we say that this is component of V in the direction of U. So, oh, a lot of terminology. Yeah, component of V in the direction of U. Yeah. And also we say that magnitude of projection of U, I'm sorry, projection of V onto U, this one. This is also, we say that scalar projection of V onto U. Yeah, because scalar means the real number, right? So we take the magnitude, then we get the number, right? That's right. Okay. Oof. All right, so let's talk about this. Okay, then we said in the beginning, so we following vector projection of V onto U, right? So didn't I same direction of U? So it's the same direction of U, right? Okay, so the unit vector we want to express as the direction of U, all right? So that will be dot product of two vectors, U, and then, so 1 over magnitude of U, and then U. Yeah, that's the form of unit vector. Okay, then we can express this one as dot product, and then the denominator has magnitude of U squared, and then U. Yeah, is it okay? Okay, so let's do example. Find the projection, correct? Projection of V onto U, right? So we have V equal to 3, 5, 1, U equal to -1, 4, 3. Okay, so we need to distinguish, right? If we don't have a hat, that means just a regular vector, yeah? If we have a U hat, that means unit vector, right? Okay, now we are applying this formula. Let me copy. Copy. Ooh, ugly. Never mind. How about this? Copy. Okay, projection V onto U, right? So we can just exactly same formula apply, right? We don't have to change any letters. Okay, so there will be dot product of UV. So 3, -1 plus 5, 4 times plus 1 times 3 over square root of u squared, so -1 squared plus 4 squared plus 3 squared and square them, right? Okay, then we have a -1, 4, 3 as u, right? Okay, now the numerator, we have a 20. Okay, now we can just calculate this one because square root squared is we can simplify, right? So inside we get 26, and then we have a -4, 1, 4, 3. Yeah. Then we do distribute. Oh, you cannot see. Oh, here. Sorry. So -20 over 26. Oh, and then we can simplify it too, right? So simplest form, which is, let me write down for you. -20 over 26. Let's just simplify. I say that, right? Okay, -10 over 13, 40 over 13, 30 over 13. Yeah. Okay. Try one more. Okay, find the projection of V onto U. So V equal to 6, -4. U equal to 3, 1. Let's just copy this one. Copy. And that will be same process. So 6 times 3 and -4 times 1 over square root of u 3 squared plus 1 squared and 3 and 1, right? Equal to numerator has 14 over 10 and 3 and 1. We get 21 over 5, 7 over 5. Yeah. Okay, second part. They say that orthogonal complement. So let me write down first and I'm going to explain to you. So number 2, orthogonal complement So in other words, this is the vector component of V orthogonal to vector U. All right. Okay, let me explain to you this one. So if we have, I need a little lecture for this one. If we have a vector V, and then we have a vector U here, right? Okay, now we talk about the projection. So I'm standing here and project, right? Onto you, right? Make sense? So there will be project. Yeah, then we say that, oh, this was the U, right? Project onto U, right? Then we say that this is a vector P. Give it to the new name, right? Because projection V onto U, right? So new name, which is a P. So this is a new name, vector P. Okay. Then let's say that we have a vector Q here. Yeah. Sorry, my Q looks like that, right? Okay, then we knew that vector V is from vector P addition with a vector Q, right? Make sense? We learned, right? On first day. Yeah, this is diagonal method, right? I mean the parallelogram. Yeah. So like this, yeah, parallelogram. Oh, a little bit ugly. Okay. So we can say that this is, let me write down, um, projection of projection of vector V onto U, right? Then that would be P. Yeah, same as P. Make sense? Okay, this is one way we can make a projection, right? Projection. Okay, how about this way? What if we have vector V this way? Yeah, and then vector U is here, same direction with earlier. How about vector Q here? Q. Yeah. Okay. Now from the vector V, yeah, we make a projection onto the U, right? Okay. So then dot is better. Then we name this one also P. Yeah. Okay. Then that V also what? The addition of a vector P and Q, right? Same as, yeah. Can you see that? Okay. Now, we can say that we have P plus Q, which is the vector V. Then, if we want to express with a Q, right? Then we can express as Q equal to vector V minus P, right? Okay. Now, what I am talking about, or I am trying to talk, orthogonal. So P and Q are orthogonal. Yeah, we can see that, right? Q is here, P is here, orthogonal. And P is here, Q is here, orthogonal, right? So P and Q are orthogonal. Okay, then we can say that one is orthogonal complement. Yeah, so that vocabulary. Yeah, makes sense? So either P or Q be orthogonal complement. Yes? So let's say that Q be orthogonal complement. Yeah. Or we can say that P is orthogonal complement. Make sense to you? What the terminology means, right? Okay. Now let's go back then. Let's do this one. So orthogonal complement, then we have a formula already. So Q equal to the vector V minus P, right? So when they ask us orthogonal complement, that is vector component of vector V orthogonal to vector U. Yeah. Okay. So we have, let me just write down this one. Copy. Yeah. Okay. Then what's the P? So P is even here, even there, right? Projection of V onto V. I'm sorry. Projection of vector V onto U, right? Even here, even there, right? Yeah, same as. Let me write down here. So, uh, oh, where did this one get? So let me write down V onto U equal to P. Yeah. All right. So then that means vector V minus P, P equal to that. So projection of vector V onto U. That's it. Okay. Now what's the V? V equal to 6 negative 4. What's the projection of vector V onto U? From the number 1, we found P. Okay, so that will be vector subtraction. So we have 6 minus 21 over 5, negative 4 minus 7 over 5. Common denominator, so we get 9 over 5 and negative 27 over 5. Yeah. We can check the orthogonal, right? So how? Very good. Dot product, right? Check the orthogonal. So P dot with a Q and P. What's the P? Same as a projection of vector V onto U, right? Dot with the Q. We just found the Q. So, oh, here you go. 21 over 5, 7 over 5, dot product with 9 over 5, negative 27 over 5. What do you get? So 21 over 5, 9 over 5, plus 7 over 5, negative 27 over 5. Do we get 0? Yes, very good. So thus P and Q are orthogonal. Okay. Oh, you cannot see. Very sorry. All right. So we understand another terminology, which is orthogonal complement, right? Yeah. Okay. Now we have two applications. So let me make a copy and paste here. Okay. So we have application here. Why we are using that? The projection. So I brought the one application. So a 2,300 pounds truck sits on ramp inclined at 22 degree. Find the magnitude of the force required to keep the truck from rolling down the ramp, right? Okay, so we give it to the force, like a first letter F with a vector notation. So look, going I direction here is 0, right? So 0I, and then this is Y direction. Y direction coming down is negative because down, right? So negative 2,300 J direction, okay? All right, so we have a two dimension here. So XY, so XY, what's the X in terms of degree? So cosine theta, then Y is sine theta. So they say the incline at 22 degrees. So cosine 22 degrees, sine 22 degrees, right? Okay, now I just say that when do we use that vector projection, right? So in that kind of application, so I brought up that formula, right? So we using this one, okay? After we using this one, they say the magnitude, so we take the absolute, not absolute value, the magnitude, right? Okay, so that will be, I just follow that projection of vector F onto V. Yeah, so that is this one project onto the vector V. Yeah, so those not inclined, right? Does not fall down. Okay, so that means just following that UV, so I'm gonna make a V and F with the dot product, right? Over U squared, which is the V squared with the magnitude, and then U, so it's V, right? Make sense? I just follow, say, ooh, I, I just follow same formula by using that, right? Okay, let's apply. So vector dot product. So that will be V, which is cosine 22 degrees, sine 22 degrees. Let me write down. And sine 22 degrees. Can you please calculate what is the cosine 22 degrees, sine 22 degrees? And dot product with F. F was 0 and negative 2300, right? And over V squared, which is square root of cosine 22 squared, right? And sine 22 degrees squared, and then square them, right? And then we have cosine 22 degree, sine 22 degree for the V, right? Okay, now let's calculate. Cosine 22 degree, which is 0.93. We're using radians, right? So the value is 0.93. And then dot product with a 0, right? 0. And sine 22 degrees is 0.37. So we have a negative 2300 over the denominator. So cosine theta squared plus sine theta squared, which is 1, right? So note. Cosine squared theta plus sine squared theta. Yeah, that kind of a concept we are using that, right? Okay, then the numerator is 1. We don't have to calculate. Then we will have, how about that? And cosine 22. We have the number, isn't it? Just forget it, the number. Hold on. Okay. Sine 22 degree. Okay, inside we get negative 861.959, no, 595. And then cosine 22 degrees, sine 22 degree. Yeah. Okay. Now we do magnitude. Projection of F onto V. That would be make a negative 861.595 squared, right? And then magnitude square root of cosine 22 degree square plus sine 22 degree squared, right? Okay, we know that this is 1. That would be 861.9, kept saying that, 595 pounds. That's the pounds notation. Yeah, this is the pounds, right? Yeah. Okay, any question? Okay, let me bring another application. Okay, so this is the last application. And then we have formula here, definition. When constant force is applied to object, so object moves in straight line from point P to point Q. The work W done by force F vector. Yeah. Acting angle theta from line of motion given by. So this is the formula. So work done. W equal to the vector F, dot product with the PQ. And then we have angle related, then magnitude of that force, and then magnitude of PQ of a vector and cosine theta. So I mentioned that PQ is displacement, object move. And then this is the question in the bottom. So suppose a child is pulling wagon with a force having magnitude of 8 pounds on the handle at angle of 55. If the child pulls the wagon 50 feet, find the work done by the force. So we have the angle related. So we are using magnitude of F and the magnitude of displacement and then cosine theta, right? Okay, let's do it. So work done equal to magnitude F, magnitude of PQ, cosine theta, which is, what's the magnitude of F? Very good. That's the 8. And then what's the displacement? 50 feet. Very good. And cosine, what angle we're using? Cosine 55. Very good. Now, can you please calculate? Yeah, so we have 400.574, which is 229.43 feet. That's the feet, right? So feet. And this is a pounds. So pounds. Yeah. That is the unit. Okay. So any question? We done. And this is a little bit long section. Yeah. Okay. Thank you for watching. You have nice day, nice evening. I'll see you tomorrow in section 2.4. Thank you very much. Bye.